Key is a diagram or sets of questions by which we are going to find out the names of some animals, plants or insects through looking at their features. So we're going to see the two criteria for the key. The questions should describe the differences between the animals or plants. Second criteria, the questions need to be yes or no question. As we have seen the criteria of the key, right now I'm going to take you through one of the keys which describe the differences between vertebrates. As you can see over here, we have classified the vertebrates based on their differences, the differences between them. So starting with the first question, does it have fur? We have two answers for this question, either yes or no. If the answer is yes, then we are talking about mammals, as you can see. If the answer is no, this is going to take us to the second question, does it have feather? If the answer for this question is yes, then we are talking about birds. If the answer is no, then we are talking about the third question, which is, does it have dry skin? This has yes or no answers as well. If the answer is yes, then we are talking about reptiles. If the answer is no, this is going to lead us to the last question, does it have scales? If the answer is yes, then we are talking about fish. If the answer is no, then we are talking about amphibians. This is how we go through the key diagram, guys. But we can find the key in two ways. One way, which is the diagram that we have discussed together. The second way is by the help of a set of questions. Speak about the second way. As you can see on the board, here we have the set of questions which is describing the same key that we have discussed earlier. So first question is coming on top. Does it have a fur? Yes, it's a mammal. If no, then we need to go to the second question. As you can see, we write yes. If the answer is yes, we write the name of the animal. If the answer is no, we are going to write the number of questions in which we need to visit. So as you have seen in the first question, no, go to question 2. Question 2, does it have feather? If yes, then we are talking about a bird. If no, then we are talking about question 3. Question 3 states, does it have dry skin? If yes, the answer is reptile. If no, we need to visit question 4 as it's visible over there. Question 4, does it have scales? If yes, then we're talking about fish. If no, then we are talking about amphibian. So it's all about looking through the features, the visible features of animals and guiding you through the questions. If the question is yes, we write the animal name. If the answer is no, then we write to each question that we need to go. We have taken the variation and we said variation is the differences between the individuals of the same species. And as you can see in the picture, we have people that have different skin colors, that have different eye colors, different hair colors. All of these things are called variation because these differences belong to the same species of the individual, belong to the same species, which is called Homo sapiens. And then we have spoken about the factors behind the variation. We said we have two different kinds of variation. We have inherited variation and environmental variation. Inherited variation. We said the variation based on the inheritance came as a result of passing the genes or the information, the DNA, from the father and the mother toward the offspring. As you know, the children usually look a little like their father and a little like their mother, but they will not be identical to either of them. That's because the offspring or the baby has taken part of the genes, half of the genes from the father, the other half from the mother, and that's why the baby will have a small part of the father's small information or genes, and the other half of the gene from the mother is going to look a little bit like the father and a little bit like the mother. And that's why we have an inherited variation. Let's look deeper into that. From the mother side, the baby takes the egg cell. The egg cell contains half of the DNA. On the other hand, from the father side, the baby takes the sperm cell, which have half of the genetic information for the baby. When both of them fuse together, join together in a process called fertilization, they develop the first cell of the baby. And that's the process of fertilization, and this is the core for the inherited variation. Based on the genetic information that the babies take from the father and the mother, they are going to have certain characteristics that for sure will look different than the other ones. Here are some examples of inherited variation in humans. We might have the eye color, the hair color, skin color, and we might have the looped or loopless ear, as you can see in the picture. We might have the ability to roll your tongue. All of these are based on the inheritance. Not only that, but also the gender. The gender, guys, is one of the main characteristics which is passed and determined by the genes of the father, and that's why we can have in the same family some of the siblings might be males, the other ones are going to be females. That's based on the genes carried from the parents toward the offspring. As you can see in the picture, we have different eye colors and we have the differences between the ears. One is looped ear and the other one is loopless ear. All of these variations are belonging to humans, which are found in the same species, which is called Homo sapiens. The other factor is called environmental variation. Environmental variation is caused by the help of the environment. I'm going to give you some of the examples that might affect an organism based on the environmental factors. The first one is climate. As you know, people that live in a place which have high exposure to the sun, they might develop darker skin, while the other people that don't have sun around for a long time in the year, they might develop a white skin. Not only that, but also the diet. If the people are eating a lot, this is going to cause an increase in the weight, so they might develop a thicker body, and people who are eating in moderation or eating less, they might develop a thinner body. So that's another way of the environmental variation based on the environmental factors. Not only that, accidents, culture, lifestyle, all of these might develop some of the variation between the humans. And remember, we're still talking about the same species, which is called Homo sapiens. The variation caused by the surrounding is called environmental variation, and that's the second example of the variation. Here are some features that are caused by environmental variation, like the language, like the religion, like the color of some flowers. You know, some flowers might develop a might become blue color if they are found in acidic soil, and they might become a pink color if they are developed or planted in an alkali soil. So based on the pH of the soil, we might have different colors, and that's another example for environmental variation. In order to show you the two factors together, the inherited variation and the environmental variation, I want you to imagine that we have two identical twins, twin A and twin B. We're going to say that twin A and twin B are identical, so they carry the same genes from their parents, so we have no inherited variation. But we might expose twin A to the food more than we have exposed twin B. So twin A is going to eat a lot and is going to develop a heavier and taller body than twin B. So changing one factor, environmental factor, which is the food, have affected the body of the twins. One have developed a heavier body, taller body, while the other one have developed a slimmer body and might be shorter body. So the food or the environment have affected the growth of the body. Okay, at the beginning, let's define the selective breeding. Selective breeding is the traditional method for improving crops and livestock, such as increasing the disease resistance or the yield production. So basically, we're going to look into a favorable feature, and based on this favorable feature, we're going to increase it among the offspring. Natural selection and selective breeding can both cause changes in animal and plants. The difference between two is the natural selection happens naturally without the intervention of the humans, while the selective breeding takes place by the help of the humans. So for this reason, selective breeding is sometimes can be called as artificial selection, because it's not made by the nature, it's made by the humans. So the aim of selective breeding is to look for a favorable feature. But as an example, we have too many favorable features. Today we're going to discuss 3 of them. It can be the cows. We can improve or enhance or support the cow that produce more milk than the others. We need to increase the yield of milk production. The second feature that might be there, we might increase the percentage of the chicken that produce large eggs. Or we might look for the wheat plants that produce lots of grains. So mainly our aim is to increase the yield of production, either for milk, eggs, or even the plants. That's to be able to cope up with the higher population that we have developed recently in the last few years. So the scientists had to look for a way to increase the milk production, or the size of egg, or the plant grain sizes. All of these have taken place through the selective breeding. Here I'm not talking about natural selection, I'm not talking about something which was made by the help of the nature, but I'm talking about something that was supported by the humans. Okay, so selective breeding takes place over many generations. These are the main steps involved in the selective breeding. The first step in order to have a selective breeding, or to increase the percentage of the cows that can produce more milk, is to decide which characteristics are important enough to select. We need to have an aim. Is our aim to get more milk, to get more beef, or to get larger eggs, or to get larger grain sizes? We need to be so specific when it comes to the characteristic which we are needed. The second point is to choose the parent that show these characteristics. We are going to look for the parents, like male and female cows, the female cow that has produced lots of milks, and a male cow that has like a mom or a female in the family that produce more milk. We get these two parents, and then we're going to choose the best offspring from these parents to produce the next generation. We'll make these parents to breed together. When they breed together, they are going to have too many offsprings. We're going to pick those who are producing more milk, and then we're going to choose them to breed again to get offspring, and so on. So the process is to choose the best parent and the best offspring that meet our need, that produce more milk, or that have lots of meat, or that have a large egg size when it comes to the chicken, or the one that has a larger grain size when it comes to the plant. Good. In this picture, as you can see, we have different dogs. These dogs were developed by the help of selective breeding. People were breeding different dogs in order to get a certain feature, a favorable feature. As you can see, these dogs were not looking the same as their ancestors, but they look totally different than their ancestors. As we have seen how the selective breeding takes place by the help of the humans, I want you to remember the first lesson, or the first video that we had together, where it was discussing the introduction for term 3. We said in the natural selection we're going to discuss the examples of giraffes, and we're going to know how the giraffes that had short neck extinct, and the giraffes that had long neck survived based on their ability to get the food from large trees. So basically, in order to give you the idea of the natural selection, we need to look at the giraffe as an example. Natural selection is a process that takes place by the help of the nature. If the organism has a certain feature that is going to help the organism to survive in its habitat, it's going to survive. while the other organisms that don't have these characteristics to survive in the habitat, they are going to extinct. So basically, through millions of years, whatever the animals and the plants that we have at the moment, these are the animals or the plants that survived due to the adaptation and the natural selection. We're going to discuss one of these examples, which is the giraffes. As we have discussed earlier, we had two different kinds of giraffes. We had the giraffes with the shorter neck and the giraffes with the longer neck. And by the time the giraffes with the shorter neck didn't get their food, the more they extinct, and the giraffe with the longer neck was favored and was adapted to survive in the habitat. Right now we're going to make a small comparison between selective breeding and natural selection. See, for both of them we have population of organisms that show variation, and the variation is basically based on the genes. Then for the selective breeding, the people, humans, are the ones who are deciding which organism is going to breed in order to pass this characteristic to the offspring. On the other hand, the natural selection, it's only the nature which decide which characteristic will be passed. That's through the adaptation. So individuals that have characteristics that provide the best adaptation to their habitat are more likely to survive. So in the selective breeding, as humans have decided, so only the individuals with characteristics that people wanted are going to breed, while on the other hand, for the natural selection, only individuals with the best adaptation survive. So selective breeding is mainly about the humans. They are deciding which characteristic will be passed through which parent and which offspring. In the natural selection, the nature is deciding which one should be passed, which feature should be move on and survive in the habitat. It's based on the adaptation and surviving in the habitat. At the end, what we're going to get at the end of both processes, that the individuals of the species are going to have a favored feature. This feature either decided by human in selective breeding or by the natural selection in case of the nature. So we have in both sides a characteristic. In one side humans are deciding, in the other side nature is deciding. I hope you have understood the differences between the natural selection and selective breeding. That's well needed when it comes to discussing the evolution for Charles Darwin. So please keep this lesson in mind, and we're going to continue later the story of the natural selection along with Charles Darwin. Charles Darwin theory of evolution by natural selection. Charles Darwin was an English naturalist who studied variation in plants, animals and fossils during a 5-year voyage around the world in 19th century. Darwin visited 4 continents on the ship of HMS Beagle. Darwin observed many organisms including finches, tortoises and mockingbirds during his 5-week visit to Galapagos Island. The Galapagos Island is found near the Ecuador in the Pacific Ocean. He continued to work and develop his idea once he returned from his voyage in England. After Darwin came back to England, he started to do some analysis for his data, and he came with a proposal. So Darwin proposed that individual organisms within a particular species show a wide range of variation for a characteristic. So it's like a species or individuals that are found in one species might look different, exactly like humans. Humans are looking different from each other. Individuals with characteristics most suited to the environment are likely to survive to breed successfully. So if an organism is adapting in an environment, that's going to make more possibility for the organism to grow and breed in order to get more offspring. But if an organism cannot survive in a habitat, the organism will not be able to breed nor to survive in this habitat, and you're not going to see it anymore. The characteristics that have enabled these individuals to survive are then passed on to the next generation. As this organism has survived due to certain characteristics and is going to breed, so the organism is going to pass these genes to the offspring or to the babies. This theory is called natural selection. Basically, everybody requires energy in order to do our daily activities. Not only that, but also thinking and moving the hand to drink or eat. These movements, these tiny movements, are also requiring energy, and we tend to get our energy from the food as a chemical store for the energy that our body can depend on. Not only humans require energy, but also the machines require energy. If we're talking about the home appliance, they require electricity. If we're talking about other machines like cars, they tend to require fossil fuels as a source of energy. If we're going to look at the consumption of energy, we can find that the majority of the energy that is consumed around the world basically goes for the industry. And then the second largest amount of energy which is consumed by the transport, and then followed by homes and offices. Homes and offices are taking the smallest amount of energy consumption across the overall energy consumption. In industries, we use this energy for making things, as everyone uses things that are manufactured. So industry came as a result of the increase in our needs, and by the beginning of the industry, we have started to consume more and more energy, as the larger machines and factories tend to consume huge amount of energy in comparison with the human being. For the transport, in order to make the ship and the airplane along with the cars move from one place into another, we used to consume huge amount of energy by the help of these machines. So we need energy to travel around, and this energy is consumed by the devices or the machines like cars, airplanes, along with in homes and offices, along with the schools. We use energy for heating, cooling, cooking, lighting, and so on. We have different purposes to use the energy inside our homes, so you can look around and see how we can consume the energy inside the home. Scientists have found strong link between the development along with the energy consumption. They have found that the developed countries, they tend to consume more energy per person when it's compared with the other countries. So the developed countries, they tend to consume more energy as a result of having more cars, they have bigger houses, they have water treatment process, they are consuming more goods and more manufactured stuff. So all of these are making the consumption of energy very high when it's compared with the developing countries. This chart represents the amount of energy which is used by a person within a year. You can find that the highest amount of energy consumption per person per year goes for USA, as the people over there consume a huge amount of energy because they have more cars, they have bigger houses, and they have lots and lots of industries going on over there. So all of these are representing a huge amount of energy in comparison with Europe, which have a lower amount of energy consumption per person per year. Middle East goes for the third place, China, Latin America, Africa, and ending with India. So this chart is representing how a person, based on his place, can consume more or less amount of energy in comparison with another person in a different place. The point of today's lesson is fossil fuels. So in the fossil fuels, we are going to discuss the types of fossil fuels. We are going to talk about the chemical stores of the fossil fuels, or as fossil fuels. We're going to talk about where the energy comes from, and we're going to talk about generating electricity. The energy resources we use around the world can be split into different categories. The first large category is the fossil fuel, which is representing the oil, the coal, the natural gas, followed by a renewable energy resource. I want to ask you a question. Why the fossil fuel is considered to be one of the most important energy resources on the earth? I want you to think about the answer. Fossil fuels are stores of chemical energy. It's easy to send or to transport the chemical fuel from one place into another. If we're talking about petrol, so petrol can easily be transported from a place into another, or we can put some amount in our cars where it's going to send us for hundreds of kilometers. So fossil fuels are stores of chemical energy. The energy is released when we burn these fuels, and we're talking about a good amount of energy. So that's why, due to the convenience in transporting the fossil fuel from one place into another, and due to the large amount of energy produced by the help of the fossil fuel, we can consider them a good source of energy. As the fossil fuels are considered the good or the better source of energy that we have on Earth right now, so let's discuss how the fossil fuels are made. Fossil fuels are found under the ground as coal, natural gas or oil. The coal is made by the help of the plant that did not decay for thousands of years, and by the help of the pressure, high pressure and high temperature, the plant has changed from a plant into a coal. While the oil and the natural gas were made by the help of the sea creatures that did not remain, that did not decay. They are covered under layers of sand, and this sand was applying pressure on the sea creatures to change them from a sea creatures, remaining of sea creatures, into oil and gas. At the end, we are talking about the fossil fuels, but fossil fuels, they have some of the environmental impact. They are not really that pure energy because they tend to pollute the environment. As a result, people tend to use more electricity than fossil fuels. Some of the electricity that is generated can be generated by the help of water, wind, while the other amount of electricity that is consumed right now are coming from the burning fossil fuels. So most of electricity is generated in the power stations at the moment. They are coming from the fossil fuels, especially burning coal and gas. So let's start our lesson by reviewing a renewable energy resource. We can state that about 1/8 of our energy comes from the renewable energy resources that include the wind, water power, solar energy and biofuel. Renewable energy resource cannot be used up so they can renew itself. That's why they can be considered as a good source of energy that are going to long last forever. We have 4 different renewable energy resources, starting with wind power, water power, solar energy and the biofuels. First of all, the wind power. Wind power is a large place that is generating the electricity by the help of the wind. So the wind can turn the windmill. When the windmill is moving, the windmill is going to move the wind turbine, which is going to generate the electricity. So basically we are changing a kinetic energy or a movement energy into an electrical energy. A river can turn a large wheel by the help of the water. This wheel will be moving. When this wheel moves, it's going to make the turbine moves. When the turbine moves, it's going to start generating electricity. So we are generating electricity by the help of the movement, so changing kinetic energy into electrical energy. And the electricity which is going to be generated by this way is called hydroelectricity, because you are using water in order to generate the electricity. Not only that, but also the waves along with the tidal current, they can also generate electricity. So any purpose which is using water in order to generate electricity can be called hydroelectricity. Then we'll talk about the solar energy. The solar energy is the new fashion of generating electricity, as we tend to have the solar cells. Solar cells are going to collect or absorb the sunlight and then changing it into electricity. Nowadays it's found everywhere around the world. Mostly in Qatar you can find it in the signals, where the signals are operated by the help of the solar cells. The sun is hitting the solar cell change the sun or the light into electricity. At the end we're going to talk about the biofuels. Wood is a biofuel that many people around the world rely on. Crops such as maize along with sugar cans can be harvested and fermented to produce a liquid fuel for cars and trucks. So these crops or these products can be used in order to get fuels by the help of fermentation. The problem is we need to get these kind of foods in a larger amount than our uses, because we need to take part of it for us to feed on, and the excess need to be used as fuels. This is one of the problems that can be facing the biofuels. Then we're going to talk about the non-renewable energy resources. The non-renewable energy resources, or mainly the fossil fuels, is our main deal of today's lesson. We have the coal, the oil, the natural gas. These cannot be considered a renewable energy resource, because you cannot find the coal or oil or natural gas renewed or replaced naturally easily. They take millions of years in order to make them, so we cannot replace it easily, and that's why this fuel is called a non-renewable energy resource. And then nuclear power. People use nuclear fuels such as uranium. These are stores of nuclear energy. The nuclear fuels are not burned, but their energy is released in a nuclear reactors, where the nucleus is going to be split in order to produce a huge amount of energy. I hope you have enjoyed today's lesson, and see you next time.